Unit 7, Polynomials. And this particular lesson is polynomial transformations and graphs. I'm not going to spend a lot of time on a lesson because it's exactly the same as what you've seen before. You can find the y-intercept of a polynomial function. You can describe the end behavior of a polynomial function. You can identify and use transformations to graph polynomials. You can identify the domain and range, including restricted domain and range of a polynomial. And you can identify the increasing and decreasing intervals of a polynomial. Let's get started. First, your parent functions. There's x cubed, x to the fourth, x to the fifth, x to the sixth. Note the end behaviors, x-intercepts, y-intercepts, similarities, and differences. Okay, we've already talked about end behaviors. When it's an odd degree, it's down, up. When it's an even degree, it's up, up. And then you reverse that if it's reflected. Everything starts out at the origin and then goes right one, up one. The next one, when you go right two, that depends on whether you're squaring it, cubing it to the fourth, fifth, or sixth power. Now, the negative on the outside reflects it over the x-axis. How does a reflection over the x-axis affect the y-intercept? Well, if it was above, it's below. If it's below, it's above. Notice here, if your y-intercept was 1 when you reflect it over the x-axis, it becomes -1. If you reflect it, okay, over the x-axis, the y-intercept doesn't change, but the x-axis changes sign, or the x-intercept changes sign. Reflection over the y-axis, okay, over the y-axis. How does it affect the y-intercept, and how does it affect the x-intercept? Notice when I reflect over the x-axis, the x-intercepts are reversed. They become negative. The y-intercept stays the same. Translating. Okay, if I move it left and right, I'm changing the x-intercept by adding or subtracting that much to them. Okay, and again, I've given you all of this written out so you can take and read through it if you want. But you know how to do this. Moving up and down, okay, the y-intercept changes by however much is up and down, but then so does the x-intercept. Okay, notice that by moving it up, it may change where I'm crossing the x-axis. Stretching and compressing, same thing, inside or outside. Okay, when you're looking at something, think about how it would change. What would change? Does the end behavior change when you stretch or compress? No. Okay, here's some more stretches and compresses. Just look at these three and think about what's going on. The end behavior doesn't change. The y-intercept changes, but the x-intercept does not. As a summary, transformational approach to graphing. You have your vertical stretch or your vertical compress. Here, you're going to move left or right. Here, the K, you're going to move up or down. And if we do have something on the inside, we try not to, but that would be a horizontal stretch or compress. This is the basics, though. With this, you should be able to graph just about anything along with your knowledge of end behaviors. The one other thing I did want to mention to you is x and y intercepts. Remember that to find an x-intercept, okay, think about an x-intercept is here, which means that y is 0. So set y to 0, solve for x. On the other hand, if you're looking for the y-intercept, that would be anywhere here, and you've got a table of values, you're going to set x equal to 0 and solve for y. Now, if it's a function, you'll only have one y-intercept. X-intercepts, you could have multiple. Okay? really, for this particular activity, your best bet is to work on the problems. Make sure that you know how to indicate in behavior, and make sure that you understand that increasing and decreasing intervals, it's over what values of x is y increasing, over what values of x is y decreasing. Okay? That's it. Again, most of it is review.